As a follow-up to the distributive property notes you took on mostly expanding or removing parentheses, now we're going to talk a little bit about factoring. So when we factor an expression, we're entering or adding parentheses to the expression. And most of the time you'll see either a plus, but sometimes a subtraction sign inside those parentheses. And the number that ends up on the outside is going to be the GCF of the two terms in the expression that you start with. Inside the parentheses will be the leftover factors that we would multiply the GCF by to end up with that expanded form. So as a reminder, the expanded form is when we do not have parentheses. And the factored form, and the factored form
Michael Cummings,
is
if you're in the building, can you please
2.
come to the main office? Michael Cummings, if you're in the building, can you please come to the main office?
Difficult to get a video done right now. So the factored form of 18a subtract 2 is 2 multiplied by the quantity 9a plus 1. If you take a look here, we can see that 18a and 2 have a greatest common factor of 2. And when I take and divide both of those values in my expression by 2, I end up getting 9a subtract 1. And that information ended up on the inside of my parentheses in that factored form. So another way to think about this is to say, for example, if I have 5a plus 30, what are the factors for 5a and 30? So if I start this, I would say, well, 5 times a is 30, and I know 5 is prime. So the factors of 5a are just 5 times a. And the factors of 30 are 5 times 6,
Michael
and
Cummings,
5
if you're in
is
the building,
prime.
can you please
My
come to the main
goodness.
office? Michael Cummings, if you're in the building, can you please come to the main office?
And the factors of 6 are 2 and 3. 2 and 3 are both prime. So my factors for 30 are 5, well, let's start with my lowest number first, 2 times 3 times 5. To find the GCF, I'm going to circle the factors that are in common. So my greatest common factor here for 5a and 30 is 5. That means that I'm going to take my factored form and place into it 5 on the outside of my parentheses. And what am I left with? So this is what's really nice about using this method. I'm left with a, and a is going to fall right into the first part of my parentheses. And in 30, I'm left with 2 times 3, which is 6. So what's really nice about the distributive property is once I've factored 5a plus 30 and have 5 multiplied by the quantity of a plus 6, I can actually check my work. And I can say, well, if I distribute or expand this expression, I would end up with 5 times a plus 5 times 6. 5 times a is 5a plus 5 times 6, which is 30. And this is the expression I started with. So I know that I've done this successfully. So looking at this one, 12x plus 18, if I want to factor it, my goal here is to end up with the GCF on the outside of my parentheses, and then the two factors that go inside that parenthesis or that grouping. So if I look here, I can find that 12x is really 12 times x, and then I'm going to break down our factors of 12. 12 is 3 and 4 is 2 times 2. So here are my prime factors, and we can't do anything with that x. 2 times 2 times 3 times x. And my factors of 18 are, let's say, 6 and 3. 3 is prime. So I'm left with 2 and 3. And then I'm going to write down what I've got. So 12x gave me 2 times 2 times 3 times x. And 18 gives us 2 times 3 times 3. Circle the ones that are in common. I have a 2 in common, and I have a 3 in common. So 2 times 3, my greatest common factor is 6. So as I said before, I can now find, see if I can find a different color real quick. I can now say that I'm left with 2x, and I'm left with 3 from that 18. So 6 multiplied by the quantity of 2x plus 3 will be the factored form for the expression 12x plus 18. I just want to show you one more way to think about 12x plus 18 once you found that your greatest common factor is 6. So if I've already identified that I can divide both of these numbers by 6, the number I divide by goes on the outside of my parentheses. And then I can say, back to my black pen for a moment, 12 divided by 6 is 2x, 18 divided by 6 is 3. So now this expression here can be placed over into my parentheses, giving me 6 multiplied by the quantity of 2x plus 3. How can I check to see that this is correct? I can check to see by quickly doing 6 times 2x plus 6 times 3. 6 times 2x is 12x, plus 6 times 3 is 18. So if you need to, go ahead and re-watch different parts of this video, but then I'd like for you to try out these 3 that are on the screen. Number 1 is 8y subtract 12. Number 2 is 30w plus 10. And number 3 is 16x plus 48. So remember, you want to think about finding the GCF, and then you are going to go ahead and do a division to find your other factors. So that format becomes on the outside, GCF, and then on the inside, your factors of the numbers that are left. Well, here's the question. How did you do? Our 8y subtract 12 will become, with the GCF, 4 multiplied by the quantity of 2y subtract 3. And our 30w plus 10 becomes, GCF is 10, so 10 multiplied by the quantity of 3w plus 1. And the last one, we have 16x plus 48. Greatest common factor is, let's see, I hope you got 16. 16 multiplied by x, or 1x, plus 3. So what happens on that last problem if you had 16x plus 48 and you have your answer to be 8 times 2x plus 6? This is a really good start to your factored expression. Oops, good start. But I need to notice that both 2x and 6 still have a common factor, and I could actually factor out another 2. So if I think about that, if I say, well, here, I'm going to divide by 2 and divide by 2, then I would have x plus 3, but I have to remember that this 8 was in front, and I also have to then take care of that 2 from over here. So I've actually factored out 16 multiplied by the quantity 1x plus 3. So that's a good way to check your work when you've factored, to know that you have definitely found the GCF of the terms in that expression. I hope this video has been helpful, and we will continue to practice in class and on our homework calendars.